Assalamu alaikum wa rahmatullah. Welcome everyone to IE 342 Quality Control. And today we'll continue with the chapter 6, Control Charts for the Variables Data. And we have covered in the last part the control charts for variable when we have the sample size is small, within 6 sample size, and we have used the X bar R control chart. Today, when we have a sample size larger than this number, and scientists or specialists, they have set up the n greater than 10 or even equal to 10 is the number of size or sample size where you use a different control chart, which is the X bar S control chart. So the difference between X bar R and X bar S is the sample size. When we have a problem that needs us to use a control chart, first we have to identify whether this data is variable or attribute. If the data is variable, then we have learned so far the X bar R, and today we will learn the X bar S. What is the decision metric to decide between the X bar R or X bar S is the sample size. If we have a sample size greater than 10, then we use the X bar S. If it is less, then we use the X bar R. Before we proceed with the X bar S control chart, there is an important information that we haven't talked about in the last lecture about the X bar R, is the sensitivity of the variability for each control chart, because when we do develop X bar R control chart, we develop X bar control chart and R control chart. The X bar control chart is monitoring the variability between the samples. And the reason is if we have a sample size, let's say 5, X bar representing the average for all those 5 readings, whereas the R chart is the one who measures the variability within the sample. And that is the reason how we calculate the R. The R is calculated within the sample by subtracting the largest number in the sample minus the smallest number in the sample, whereas the average over the X bar is taking the average for every sample and then you compare them together. But that for the R chart is different. Is within the sample you are subtracting the largest number and the minimum or the smallest number. So the R chart detecting the variability or measure the variability within the sample and the X bar between the sample. This is very important information to identify what is the variability or sensitivity for each of the control charts. So let's move on to the X bar S control chart. And we said when you have a sample size large, then we use the X bar S. The formula is pretty easy as we had for the X bar R. You need to know how to develop the control chart in hand and on the software application. It will depend on the problem that you will have, because you may have information that only have the parameters value, not the measurement. So in that time, you have to construct the control chart manually on hand. Or maybe the question asks you only to formulate and determine the upper control, lower control limits. So in this case, you don't do the Minitab or software application. But if you have a case where you have a set of data and ask you the question to use a software application to develop the control chart and then upload the figure of that control chart and analyze it and see if there is out of control, what are you going to do in that case? Then you use the software application. So we need to know how we do the control chart both manually, like here in the formula, and using software application. For the manual development of the control charts for X bar S, as we did for X bar R, we have a control chart for the S and control chart for X double bar. Those constant B4, B3, A3, all of them can be found here in this table, which is attached here in this updated slide, and I will upload it later on our website. Here where you find the X bar, the S chart needs you to have the constant B4 and B3, and here you can find the B4 and B3 based on the sample size. So we will have usually in the X bar S chart sample size greater than 10. So don't be confused if you have seen some examples using a less control sample size, for example 5 or 6 sample size. It is fine to use the X bar S, but when we talk about the examination or in the course level, we will set up the sample size to use the control chart X bar R when we have less than 10. If we have greater than 10, then we will use the X bar S chart. It is for better sensitivity analysis and monitoring, but you may see some people using X bar S where the sample size is 6, and that is not wrong, but it would be preferred to have X bar R in that time. As we said, some specialists say if you have a sample size larger than 6 or 7, it would be better that time to use X bar S. Some says with a larger than 10. So we will refer to our textbook, what it says, so we will not be contradicting to our textbook reference. So those constant values can be found from the tables which is given to you, and you can have it during the exam. A3, which is found to be here in this column, you look for the sample size and you get the value of the A3. An example here to construct an X bar R for data is given, we will see it. This is one of the things you have to know, how to develop the X double bar, which is the center line for the X bar chart, and the S bar, or the standard deviation, or the average of the standard deviation, which is the center line for the S chart. After you develop the center lines, then you can draw or develop the upper lower control for each chart. For the X double bar, we will use the formula stated here in this slide, B for X double bar plus A3 times standard average of standard deviation, which is here X double bar found to be 74 plus A3 from the table. The sample size given here, I believe it was 5, if I'm not mistaken. The A3, it is 1.4. So yeah, it is 5. The sample size used X bar S. This is one of the examples I was telling you. 1.429 or 1.43. That is the A3 times the standard deviation, or the average of standard deviation, which one is the 0.0094. This is the upper control. The same for the lower, except the minus sign instead of the plus sign. For the upper control limits for the S chart, we will use B4 times the average of standard deviation. The B4, again from the table here, for 5, it will be 2.09, 2.089, which is the 2.09, or 2.1 is the same. If you depend on the rounding you are using, times the 0.0094, which is the average of standard deviation. B3, it will be 0 from the table, so the lower control limit for the standard deviation is 0, and this is obvious. You want the variability or the standard deviation to be at the minimum, which is 0, whereas the measurement, it could have lower and upper control greater than 0. Those are the original readings or measurements. My advice, you copy those numbers, you try to copy them on the Minitab. I will show you another example on the Minitab, how we develop XBAR-S control chart. But my advice, you use this data to type them on the Excel or Minitab and try to develop the control charts for XBAR-S, and to check whether you do it in the right way or no. Here we have the sample number. We have 25 samples, and each sample has 5 readings. The X-bar is the average of each sample, the standard deviation for each sample, and then we calculate this average of standard deviation by adding all the standard deviations, dividing them over 25. And for the X double bar, as we did for X bar R chart, the same. We will add all the averages and get the average of the averages by dividing those readings over 25 to get the 74.001. Then we construct the control charts, or for the X bar R, the X bar and the S chart. You can see this side on the right is the S chart, and for the left side is the X-bar chart. Let's share the screen and do an example on the Minitab to see how we can develop the X-bar S chart. So I will share the screen with you now. Okay, here is the data we have on the Minitab. We have the subgroup ID that is categorized the samples and put each sample with an ID. For example, sample 1 has 10 readings, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then on sample number 11, you see the code or ID start to saying number 2. That's mean I am sorting my data using a column. I'm not using a row like the one I have from the textbook. You put the ID in terms of naming or numbering the samples. So if you have all these readings, you can put them in one row, and you can, for all these readings here, until sample 10, you can put all these weight readings on a row, and you say this is sample number 1. And that means sample number 1 has a 10 readings. So the sample size is 10. But instead of having them row, especially if we have, like, let's say 20 readings or so or more, that it will be too much information in the sheet and maybe it confuse you. So this is another way how you represent the data. You can put a code for the sample. So sample 1, you just put the code 1 next to the reading, and the Minitab will know that means this is sample 1, and it will calculate the sample size automatically to you. And the sample size is fixed here, it is 10. So in this case, we have sample number 2, another 10 readings, and then we have sample number 3, another 10 readings, and so on. So how many samples we have? We look to the end of the data, and we see it is end at 15. That means it has sample of 15, and the sample size is 5. Now, when we develop the control chart for the X-bar-S, we go to the control chart, we go to the variable control chart for subgroups, and we select the X-bar-S. After you select X-bar-S, here in the Minitab gives you the two options, either all observation for a chart in one column, this is what we did here, or observation for a subgroups are in one row of columns. If you refer to the previous recorded session about the control chart X-bar-R, we have done the two examples for the one column and all observation in one row. Whatever we did there, you can do it here, is the same. Here we are going to use in one column because all the data in one column, and it is categorized using the sample ID or subgroup ID. Then we will select the data, which is the weight, and here in the subgroup, you will select the subgroup ID, and then you develop the control chart. This is the X bar control chart, and this is the S bar control chart. It shows you here there is a point out of control, out of the lower control limit. What we do, as we learned before, we remove the out of control data measures, and then we calculate the control limits again, and we construct the control chart, and we see it how it will look like. So let's go back to our slides. There is a question here. Do the sample size need to be equal to each other? Okay, this is a question is going to be answered just now. In the X bar R, the sample size are fixed. Here in the X bar S chart, there are two types. When we have the sample size are fixed, like the one example we have showed just now, the sample size was 10. So every sample had 10 readings, and in that case, we had the control chart X bar S for the same exact sample size. Also, there is another type in the X bar S control chart is the X bar S control chart with variable sample size, and this is exactly answer your question. The X bar and S chart can have a different sample size, and in this case, we are going to use a different formula. The formula is basically, this is the X double bar for calculating the center line for the X bar chart, and this is the average of standard deviation, which is the center line for the S chart. It will be different than the control charts that we have just covered now. The sample size, it will be different for every time here, so every reading will have a different sample size. We will see an example. There is example in the textbook. It shows you a data, and the data here, it has different sample size. It varies between 3 to 5, and those samples readings are given in the textbook. You can refer to that. How we calculate the X double bar? The X double bar in this case will be for every reading different, because if you imagine here in this row, if I have 4 readings, then the average, it will be the readings divided by 4. Where if I have 5 readings, then the readings divided by 5. So every time the average will be calculated differently, as well as the standard deviation. Average and standard deviation center line or S chart center line will be calculated accordingly the same way as we did. For every reading, you will do the sample size assigned for that control chart. Usually in this case, the calculation will take longer, because if you have 25, then it will take from you a longer time to calculate it compared to the exact readings or the exact sample size. That is not preferred to happen, but it could happen sometimes based on the availability sometimes the production rate, or if you don't have a high production rate, then it could be sometimes that is the case. But it is preferred to have exact sample size every time, and to calculate the upper control and lower control limits, the same as we did previously for the X bar S chart. But here, the control limit, it will be different for every reading. Why? Because every reading has a different sample size, and in this case, we will use the upper and lower control for every time it will be with the table. I think it's previous here. Yes, so imagine if you have a sample size 4, then you will use the B3 is 0. If you have a sample size 6, then you will use B3 as 0.03. So every time the control limits, it will be different. And also drawing this manually, it is hard. So usually software application is needed to conduct such control chart. I will show you now an example on Minitab. From the same example I have shown you for the exact same sample size, I will show you now that is not going to be different in terms how we conducted on the Minitab or those software application. And that is the good thing about them. If you have a large sample or large sample size readings and they are varying, doing this manually, it is going to take a long time to conduct it. As we said, you are going to develop control limits for every time the readings, it will be different. You are lucky if the control, oh, sorry, let's go back. Yeah, this is how it will look like. You see how is the control limits here. Let me open the pointer. If you can see on the X bar chart, you see the dashes, those are the limits. The upper control limits are varying because the sample size is varying. The same for the lower control limits. The same here applied for this chart, except because the lower control limits was 0, because all the sample size given in that example, the B4, I believe it was, or the constant that was needed for calculating the lower control limit was 0. So the lower control limits was 0 all the time, but the upper control limit, you see them are varying every time because of the difference in the sample size number. I will show you an example now on Minitab, and I will share the screen with you again. Now, going to the same example, but I have changed the sample size here on the column 6, the C15 and C16. I did some modification on the sample size in a way that they are not constant. They are not 10 every time. Sometimes they are 5, sometimes they are 6, sometimes they are 8, and so on, okay? So we are going to do the same thing. You go to Stat, Control Charts, then for variable subgroups, and then the same X bar S, okay? I will leave this for a second so you can see how you get to the control chart in the Minitab. Now you press the same. I have done them using a column, not a row. And in this case, I will select the data from C. Pay attention, they look alike. The C2 is the weight, but C16 is weight underscore 1, because it is the similar readings, but the sample size is different. So we will press on C16, and here the subgroup ID, similar to say 1, but is going to be C15 subgroup ID underscore 1. So we will press on that, and then we press OK to develop the control chart. And you see now the X bar. If you look to the figure here in the top, I don't know if you see the pointer here, the upper control limits, you see them, they are varying because of the sample size is varying. The same for the lower control limits. Okay, here, since the sample size was greater than the sample size from the textbook example, so the lower control limit for the S chart was exceeding the 0. That's why you see them here. It is greater than 0 and sometimes, and then it goes back to 0, and then it is greater than 0 because the sample size was slightly larger than that example. Here we have around 10 to 7 or 10 to 6. There it has 4 to 5. And the same thing for the both control charts. So this is how it is different between the X bar S and X bar R. X bar R, we didn't have this case. We had a constant sample size. In the X bar S, we said that it is for sample size are large, relatively, usually in the textbook says it is 10. I've seen in other references says even if you are greater than 6, it would be better to use the X bar S chart. Maybe the question you will have in your mind, okay, what about in the exam? Maybe you give me a number that is very close between them, then I will make a decision. It will be hard. Maybe you give me 7 or 8 or even 9 or 10. Is not about confusing you. Either you will have a relative large number than 5, like 10, 11 or 12, or you will have a sample size of 5 or 6. And in that case, it will be easy for you just to identify which control chart you're going to use, okay? Let's go back to our slide. Yes, here is how it is the upper control and lower control limits being calculated, but as we said, it will be different for every reading, and that will result to the figures in the control chart. We are going to continue with the control charts for variable and some other information related to this chapter in the next video. That will be all for today. Just to have emphasized on the control charts, the most popular to be used so far, we have covered them, is the X bar R chart and X bar S chart. Please review the previous material, this one, and bring all your discussion and questions in the next meeting. I will stop the recording for now.